What if the excavators of the future were not just bigger, but smarter than entire fleets are today? Imagine a machine so massive it towers over houses, yet moves with the precision of a surgeon. A machine that never truly sleeps, that sees through dust, predicts its own failures, coordinates with trucks, drones, and control centers in real time. For decades, mining machines have grown larger, stronger, and more efficient. But the next leap may not come from steel alone. It may come from artificial intelligence. And when giant excavators become intelligent, mining may stop looking like heavy industry and start looking like something from the future. To understand where excavators may go next, we first need to look at what already exists. Modern mining equipment is already among the largest moving machines humanity has ever built. Some excavators weigh hundreds of tons. Some shovel enough material in a single pass to dwarf ordinary construction equipment. These machines are designed for punishment, heat, dust, vibration, rock, pressure, and non-stop operation. They are not elegant in the traditional sense, but there is a strange kind of beauty in pure industrial scale. And the truth is, today's giant excavators are already engineering monsters, which means the future may not require inventing something completely new. It may simply mean evolving what already worked and making it autonomous, cleaner, safer, and far more intelligent. Mining is getting harder. The easiest deposits were never going to last forever. As companies move into deeper, harsher, and more remote environments, the cost of moving material keeps rising. Fuel is expensive, downtime is brutal, human fatigue is real, and every delay inside a mine can trigger a chain reaction across the entire operation. That is why the future of excavation is not only about raw force, it is about coordination, it is about reducing error, it is about keeping machines productive for longer with fewer interruptions and fewer people exposed to danger. In other words, the next generation of mega excavators will not be built only to dig more. They will be built to think better. Artificial intelligence could become the invisible operator inside tomorrow's excavators. Not as a science fiction brain with emotions, but as a constant system of perception, prediction, and decision making. An AI-driven excavator could analyze terrain in real time, measure resistance in the ground, optimize each digging cycle, adjust force, angle, and timing to reduce wasted motion. It could detect unstable surfaces before a collapse, recognize patterns linked to mechanical stress, and learn from thousands of previous operating hours across entire fleets. That matters because in heavy industry, tiny improvements repeated millions of times become enormous gains. A few seconds saved per cycle, a few percent less wear, a few fewer failures. Over time, that can reshape the economics of an entire mine. One of the biggest changes may be where humans are located. In the future, operators may not sit inside these giant machines at all. They may sit hundreds of kilometers away inside remote control centers surrounded by screens, data feeds, and predictive alerts. That shift matters for safety, it matters for comfort, and it matters for efficiency. Because when the operator is removed from heat, vibration, dust, and physical danger, performance can become more consistent. But the real transformation happens when remote operation meets machine autonomy. At that point, a human may no longer control every motion directly. Instead, the human becomes a supervisor. The excavator handles the precise execution. The person oversees the mission. That is a very different future from the mining industry most people imagine today. Power may define the limits of future mega excavators. Today, giant machines rely heavily on massive diesel systems. That gives them range and strength, but it also creates heat, emissions, maintenance complexity, and huge operating costs. The future may move toward hybrid systems, full electrification in some environments, hydrogen support, or entirely new power architectures built for non-stop industrial work. That would not just change emissions, it could change the entire design language of the machine. Different cooling systems, different weight distribution, different maintenance schedules, potentially quieter operation, and better energy management across a connected site. The excavator of the future may still look brutal. But under the steel, it could function more like a smart energy platform than a conventional mining machine. A future mega excavator will probably not act as a lonely giant. It will be one node inside a larger intelligent ecosystem. Drones may scan the terrain ahead. Autonomous haul trucks may adjust their routes in real time. Ground sensors may monitor vibration, slope stability, and material conditions. Software may decide which zone gets priority, which vehicle gets redirected, and when maintenance should happen before something fails. In that world, excavation becomes less like isolated heavy labor, and more like a synchronized machine network. The excavator is still powerful, still physical, still enormous, but it no longer works alone. Its intelligence comes not only from what it carries inside itself, but from the data flowing through everything around it. This is where the future becomes especially interesting, because intelligent excavators may allow mining in places that are currently too difficult, too dangerous, or too expensive to operate efficiently. Extreme heat, extreme cold, remote deserts, harsh mountains, sites with limited human infrastructure. In those environments, automation is not just a convenience, it becomes a strategic advantage. Machines that can self-monitor, coordinate remotely, and adapt to changing ground conditions could keep operations running where traditional systems struggle. That does not mean human workers disappear. It means their role changes. Fewer people inside dangerous zones. More people supervising, planning, analyzing, and managing systems. The giant excavator remains at the center of the operation, but the human relationship with that machine becomes completely different. Of course, none of this comes without risk. The more intelligent and connected these machines become, the more they depend on software, communications, sensors, cybersecurity, and highly specialized maintenance. A mechanical failure is one problem. A system-level failure is another. A giant excavator that depends on data is only as reliable as the network, the sensors, and the logic guiding it. And in heavy industry, small mistakes can become very expensive very quickly. That is why the future of mega excavation will not be built on hype alone. It will depend on trust, testing, redundancy, and systems robust enough to survive brutal real-world conditions. Because in mining, technology does not get judged by how futuristic it looks. It gets judged by whether it keeps working. The excavators of the future may not look like fantasy machines from science fiction. They may look like the machines we already know, only larger, cleaner, more autonomous, and far more intelligent. Steel will still matter. Hydraulics will still matter. Power, weight, and engineering will still matter. But intelligence may become the real force multiplier. And once giant excavators can see, learn, predict, and coordinate across an entire site, mining may enter a completely new era. An era where the biggest machines on Earth are no longer just powerful, but aware enough to transform the industries built around them. The question is not whether these machines will evolve. The question is how far that evolution will go.